So this is 126, Practical Malware Analysis. I'm not on campus. They closed the Ocean campus a few hours ago. I signed up a few years ago to some kind of emergency alert from the college where they tell you when things like this are happening, and about 3:30 they said we're going to close the campus at 5 because some kind of water problem. It'll supposedly be all fixed by noon tomorrow. So anyway, so there's no use of the physical buildings tonight, so I'm just broadcasting from home, which will make no difference to most of the students. There's only a few students that came physically anyway, but that's what's happening. A couple of comments here. Open table, yeah, the dead internet problem. YouTube loses money. Oh, I thought YouTube made money. Well, Truth Social certainly has no chance of making money. Yeah, I thought YouTube made money. Are you sure of that? That's interesting. Anyway, it certainly has revenue. Maybe they have more expenses. That might explain why they're pushing real hard to ram ads into everything now to make more money. Anyway, so we're here at 126, and tonight we're going to talk about Windows internals, really, analyzing Windows programs, and then I'll show you the kernel debugging. I just updated the kernel debugging project so it works on Windows on ARM for the M1 users, which is very interesting. Most of it works just the same, but there are parts that are different, and we'll talk about that. So, by the way, in a few weeks, I've kind of canceled this class for Hack the Bay. Hack the Bay is going to be a security conference. It's local. It's going to be in San Francisco. If you go to that thing, it's worth extra credit. You'll see it here. They're going to have, it's from 2 to 6. So I'm going to be doing a workshop in the second half, and I guess they'll have talks and stuff at the start. So anyway, you might want to go to that. It's worth extra credit if you want to go. Anyway, let's talk about Chapter 7 here. Let me get it on this machine. I had it all set up on my other machine, but I'm going to do the lecture from my big Intel-based machine. I'm going to switch to the ARM-based machine for the demo because I'd just like to show you that version of it. All right, so here we go. All right, and this is really Windows internals, which is really what all this class is. Understanding how malware works is really a matter of understanding how Windows works. So the Windows API. If you write a game on Facebook, then they have an API, which is a way to make requests, and your game requests the Facebook environment to do things, and the same thing's true of Windows. Since your program runs in userland, it's launched by the user by double-clicking an icon on the desk or something, it doesn't have the authorization to touch any of the hardware directly. You can't put anything on the screen or read the keyboard or put out sound or anything like that directly. All you can do is ask the Windows kernel to please do that for you. And you do that through the Windows API. So you live on top of the operating system, and every request you make has to be processed by the operating system. That's how it works. So that's the API. And so we're going to talk about the concepts here, the notation, and some features of the operating system, of the API. So Windows has its own names to represent C data types. DWord is 32-bit unsigned integers, and Word for 16-bit unsigned. And it uses this thing called Hungarian notation. They add a prefix to the name of the variable to indicate what it is. So DW for the variable indicating it's a double word. Now this is what you get for using C. All this stuff was written in C or C# or C++, some variant of C. And C is responsible for most of the security problems in code due to memory corruption, which we're going to do a lot of in the 127 class in an upcoming semester. And it's because in C you have to carefully define how big every variable is, and then it is the programmer's responsibility to remember the limitations of that, which is in fact a really bad idea, and modern languages like Rust fix it. But unfortunately, so every time you use a variable, if it's a 16-bit variable, you're just supposed to know it can only count up to a maximum of 65,000 and change. And if you put in more than that, it'll roll over and get small again. So it's a good idea to remind your programmers constantly of exactly what type of variable they're using, because they have to be the one to notice when it's having unexpected results. So you got word and double word and handles and long pointers. More C features that are extremely powerful and extremely useful, but also extremely dangerous. You can define a pointer to the start of an array, and then you can just add to it to point to the different objects in an array to quickly get elements out of an array, but there is no nothing to prevent you from adding too much and going off the end of the array, or subtracting instead of adding and moving to some other memory area. And this is how you get memory corruption so easily. You're directly manipulating memory addresses in C, which is fast and powerful, but dangerous. Now, handles point to objects. Objects are things you create. For example, you open a window. Well, now you might want to do something with that window, like close it or minimize it or maximize it or redirect output to that window as opposed to some other window. And so you need some way to refer to it, so you find a handle. A handle is like a pointer. It's not a pointer. It's just an object. So once you have a handle, you can store it, and then you can use it to refer to other function calls that affect that object. So if you create a window, it returns a handle, and if you want to destroy it later, you use that handle as a parameter to the destroy window call, or as part of the destroy window call, so it knows which window you're trying to destroy. Now, in the file system, if you want to create a file or read a file or write to a file, there are functions that do this. Then there's malware that will create file mappings and load files into RAM. And this is one way to execute a file without using the standard Windows file execution process. Now, this is something we do quite a bit of in 127. This is how you sneak things past antivirus. You load something into memory, pretending it's data, then you change the permissions in the memory segment and execute it like it's code, that sort of thing. This is not something you normally do. For normal programs, it's something malware does to trick the operating system. So there are also special files. \\/ refers to the root of the entire system. Then you can specify the name of a server and then a share, or this thing with a question mark. And what these do is it refers to it in a different way, so you can have longer file names. And you'll see it if you use Velociraptor. When it tries to scan every file on the disk, it likes to just go down to this format where it just directly access every file on the disk without passing through, say, drive letters or anything. And so the lowest namespace is \. The device namespace is here, \\, dot \. So now you can do direct disk input-output. Normally you refer to disks, you only refer to labeled volumes on a disk like C and D, which are not really the whole disk. There's some other parts of the disk outside your C and D that are the areas of the disk used to control it. And you can refer to the whole disk this way. So WittyWorm was malware that wrote to physical disk 1 to just corrupt the whole disk. Then there's alternate data streams. We've talked about this before. If you echo 1 into foo, that's going to make a file named foo that only has a few bytes long. I guess it must have put a carriage return or something. I don't know why it's 4 instead of 1. Then you can echo more into foo:\bar.txt using the file name foo as if it was a drive letter, and you can now have 2 data streams in it. You can print foo:\bar.txt and you'll see all the 2's. So that's a second stream of data attached to the original file name, originally designed for compatibility with Apple, so you could have music, you could have the sound of the music, and then the album cover art, and then the liner notes, all tied to the same file name. All right. So the Windows registry is very important. In Linux, you have a program like Apache you can install on all different operating systems, and when you install the program, it has its own apache.conf file for the configuration that's not really integrated with the operating system at all. And that's the way Linux programs are, and that's the way MS-DOS programs were. But Microsoft decided to change that, and they created this Windows registry, which is a binary database that contains all the settings for all the features in Windows and all the features in all the apps you have installed. So every time you install an app, it creates registry folders and stores in there registry keys, they call them, and it stores data in there about the settings of that app. That's the plan. It's one place to store everything. And therefore, it's really handy for malware. You can easily use it for persistence. There's a bunch of registry locations that automatically launch programs when you restart the machine. And malware very often just adds itself to that list, so it will come back after the system reboots. That's for persistence. So the root keys are these 5: HKey classes root, current user, local machine, users, and current config. They're always the same, been the same forever. There are 5 places you start. And so these things are called keys, and the things inside them are called subkeys that look like folders, although they aren't folders. They can't be empty. That's why it always has at least one item called default with value not set. and then you got values in there, the data stored in here, and regedit is the tool you use to edit the registry. So there's the root keys. The local machine stores settings global to the local machine, kind of a clumsy statement, but these are settings that apply to every user that would log into the current machine, things like your hardware stuff. The current user only is constructed after you log in, and it knows who you are. Then it puts your personal settings here, like your desktop background, your start menu, the things on your desktop, stuff like that. HKey class's root defines the types, the three-letter extensions after the dots, how they're connected to programs. Current config stores setting about the hardware configuration, and it is built during boot up, partially during the power on self-test, when your computer reaches out and says, do I have a keyboard? Do I have a hard drive? Do I have a floppy drive? What have I got out there? It finds out what hardware exists and builds the current config here. And HKey users contains the personal settings for all the users, so HKey current user is just a subkey of HKey users. The run key is the one we mention most often in Microsoft Windows current version run. These are things that automatically start when you log on. And there's usually a bunch of them, like here's Box, Adobe, some kind of Microsoft Intelli type thing, LogMeIn, SoundMan for the sound card, and so on, some kind of Java update thing. You know, a lot of programs add things to the run key because they want to launch something every time you start. And you can just have malware added there too. It's, in fact, extremely difficult. These things are called auto-start extensibility points, places you can put something. There's also a folder where you can put a shortcut called the startup folder, and anything that's in the startup folder will be launched on startup. And there are many, many other ways to automatically launch something on Windows. So if you ask how many things are automatically starting every time I reboot my machine, there's not one place to look. There's not one list, which is the thing about Microsoft. Microsoft is an illogical, chaotic company. It's like a bunch of business executives meet who are not really very mathematical, logical thinkers and say, I need it to do this and I need it to do that. And people just add those things to the operating system. Unix is the opposite. Unix and C was written essentially by mathematicians. It's very precise, very mathematical. If there's one way to do something, they don't give you another way to do the same thing. It's very logical. It's designed by mathematical thinkers. Microsoft is emphatically not designed by mathematical organized thinkers. It's just sort of a sprawling mess of things added by different people thrown together. So you can't even answer the question, how many things are loaded automatically? There's not one place to go to see them all. The closest you have is autoruns. Autoruns is written by a very famous guy, whose name will come back, Mark Russinovich. Was an outsider who found all these bugs in Microsoft and submitted them when he was like 17, and they fixed them, and so he submitted more, and he submitted more, and they finally said, oh, to hell with it, we'll just buy his company. He started this company called SysInternals. He knows everything about Windows. He knew more about the internals of Windows than the people at Microsoft did, so they hired him and built his tools into Windows, which is an excellent decision. And autoruns is one of his many tools, and this will just look in a lot of places, 25 to 30 registry locations, to find things that are automatically launching. It is not perfect. It won't find every possible way to automatically launch something, but it does find a lot of them, and you'll see all the various things that are automatically running on your machine, or most of them anyway. So then there's registry functions, like you can open a key. This is a Windows API call, reg open key. EX means this function has been extended. There was some earlier version, perhaps in DOS or Windows 95 or something, and this is the extended version. You'll see X, sometimes XX, and so on. Reg get value, set value EX, reg get value. By the way, documentation of these will typically omit the trailing W or A, because it doesn't affect the documentation, but it does affect the size of the characters. There are two sizes of characters used in Windows, unfortunately. Wide is the international form, the 16-bit character, which is a really old version of Unicode trying to make international character sets, which unfortunately is kind of misbegotten and not good because 16 bits is not enough for all the languages, especially languages with really a lot of characters like Chinese and Japanese. So Unicode now goes up to 4 bytes per character, but Microsoft is still using this really old version of Unicode that had 16 bits instead of 8. And so there are functions that just use ASCII, which is basically limiting it only to English, or countries that use the English alphabet, and the wide characters are the 16-bit characters, and those are the two character types used natively in Windows. All right, so here's the suffixes. Like the EX means this function has been extended in some way from some earlier version. A means it uses ASCII characters, and W means it uses wide 16-bit characters. That's the sort of thing. So you'll see here, reg open key EXW. So it's been extended from some earlier version, and it's going to write a wide data in here. And here's reg set value EXW. So you can also save the registry in a .reg file. If you go into Registry Editor, you can take any key you like, and you can just export it as an reg file, which is a plain text file that just lists them all. Save it as a reg file, and reg files just are readable in Notepad. They just specify, I'm in this key, and then this sub key, this value has that value, and so on. It's and the thing about these is, every now and then you need to make a registry change on machines at a company. I used to do this. You need to put on a registry key to put in a special driver or turn off some Windows feature that we decided we don't want people using. So you could tell an average user to open regedit and go mess with the registry, and that will lead to a disaster. If you send an average person in here and they're supposed to dig down through a long path like this and then change something, they're likely to change the wrong thing and mess up their Windows. So you don't do that. What you do is you make a reg file and say, double click on this file. Even that's pretty unprofessional, because they really shouldn't have administrator rights to change that file. What would be far better would be to just push it out from the domain controller as a required update, and then you'd have something up there like a reg file or some kind of script that does it automatically. But anyway, this is one way to do it, making these reg files, a real old-fashioned way. So let's try a Kahoot. Let me get them open here. At least the reg files are easy to read. They're in plain readable ASCII, which is nice. Microsoft does an awful lot of things with proprietary binary formats, and it's nice when they don't do that. Possible malware in the real world. Virus total, yeah, detected red to green ratio around 1 to 2. Well, I'm not quite sure what you're saying. You're saying red to green ratio, you mean like 1/3 of all the programs? Well, maybe 1/3 of all the programs submitted to them are malware. Probably not 1/3 of all the programs in the world are malware. But anybody sending things up to VirusTotal, they probably have some suspect that it's dangerous. So I would believe that maybe 1/3 of the things actually submitted to VirusTotal is malware. That would make sense. Well, I think it's loading. Oh, here we go. All right, let's see what happens. All right, a pointer to an object. All right, that's a handle. Good. Pointing to something like a window. All right, second stream of data in a file. All right, that's alternate data streams here, not this punctuation mess here. All right, and which one is a root key? Yeah, this H key thing, that's what the root keys look like. I don't know what the H is for, maybe hive. They call these things root hives, I think. Anyway. All right, and which one is the sysinternals tool? All right, that's auto runs, good. All right, good. Okay, so let's talk about the networking APIs. So this all started, now originally, Microsoft did not care about the internet. They only cared about local area networks in the days of, say, MS-DOS, where you would share a printer. You get something like a laser printer, and you want all the computers in the room to share it, so you want a local area network. So they focused on local area networking, just through a switch, because the internet was not very important in, say, the early 90s. But the internet became important, and this is because the internet was a Unix production. The original purpose of the internet was to connect Unix servers together, so it was built in Unix, and that is for the libraries defined by Berkeley. UC Berkeley wrote BSD Unix, and they defined the protocols that made TCP/IP, which was the network to use on the internet, and Microsoft only got involved much later in this plan. So they imported the WinSock library, which are just the raw sockets defined by Unix. So they just took the Unix source code and ported it over to Windows, and that's what WS232 is. It's the WinSock libraries to give you Berkeley-compatible network sockets. Now, these do work these way, and if you've done the Python workshop I teach, we play with this. You can make raw sockets in Python, although you can't do them very easily in Windows anymore. But anyway, these are basic functions defined in Unix. You create a socket, then you can bind to a socket. That will attach a port to the socket, and it'll bind a program to the socket, so you know which program the data should go to. Then you can listen for data. You can accept data that comes in, and you can receive data from the socket. You can send to a socket, or you can connect to a remote socket, like connecting to a server. Those are the basic functions that were defined for Unix, and they're available in Windows through the WS232 library that lets you do raw sockets if you want to. Now, normally, no programmer actually wants to do this. You don't want to handle packets and port numbers one by one. You want that to be more automated. So anyway, on the server side, you'd have to call socket to create the socket, bind to bind a program to the socket, then listen, then accept, and then send and receive. And on the client side, you'd have to call socket, connect, send, and receive. It's really quite a lot of work to do this. So you don't normally do it that way, but here's what it looked like. Before you want to use WinSockets, you have to call the startup function to prepare it. Then you have to call socket, bind, listen, and accept. And in realistic code, you would constantly be calling the getLastError function, because you would never just do something. You would try to do something, and then if it fails, handle the errors. That's what professional programmers do. You don't let your program crash. you consider what will happen if everything fails. And in networking, it's very common that things will fail because your wireless connection dropped or something. So when you can't just assume your networking connections are going to work. In fact, you should assume they're frequently going to fail. Get cut off in the middle of a transfer, miss part of the handshake, all sorts of bad things will happen. And you don't want your program to do anything ugly when those bad things happen. So the WinINet API is what a normal programmer would use. Instead of doing these 5 steps to connect to a server and get some data, you just have a function like internet read file that will connect to the server, go to the URL, read the file, and get it down here. That sort of thing. Internet open URL, internet open, these sort of things. These are high-level functions that a normal programmer would use. They do not normally use raw sockets at all. It's too much bother. So that's another clue. A normal program would use WinINet. If it's using WS232, that's a little bit suspicious. Now, there is a whole bunch of code that's been imported, say, from Unix and things like that, and that might be a reason why it does it. So it's not necessarily malware, but it is kind of screwy for a modern program to use WS232 instead of WinINet. So if you want to jump to another part of the code, there are many ways to do it. You can jump and call our commands to jump from code you wrote to other parts of the code you wrote, or call a subroutine, but you can also jump into libraries, you can launch new processes, you can launch new threads, which are like independent pieces of a single process that can move forward independently, and we'll talk about these other things. Mutexes, services, and component object models are things that run in the background that provide service for other programs, and exceptions are real important. Exceptions are interrupts. These are things that happen that require immediate attention, so programs stop proceeding to the next instruction. It stops and transfers control to some other code, which responds to something like the user pressed a key, something came in on the network, somebody performed an illegal instruction. These cause exceptions. So the libraries are things that share code. And we talked about it before, dynamically linked libraries, so your program can dynamically link to it when it runs. And this is the most common way for malware to sneak into your program, is by tricking an existing program into loading a malicious library. So you do not change the code that the developer wrote, you add code to the code that's running, which the malware author wrote. And we do this in several other projects. Now, you could prevent this with static libraries, where every program has to make its own copy. Like if you're going to use WinINet, every program would have its own copy of WinINet included in its own code, so it doesn't share it with anybody else, and you can't trick it into loading a wrong library. So that would be more secure, but it would be bigger, take longer to load, and consume more memory, so Windows almost never does that. Neither does Linux anymore. The advantages of dynamic linking are just so large, even though it's risky. So it makes your code smaller, and it makes the code load faster, and you can also purchase software written by somebody else, and Microsoft is very much oriented towards this. The purpose of Microsoft is to create an operating system to make money. They've never pretended anything else. Bill Gates' contribution has always been to make a business that makes money out of this. So he thinks you want to start a company, you want to say make a game, and you don't know how to code all the pieces of your game, so you buy code pre-written from somebody else to do something like draw something on the screen and things like that. Or you're a big game company and you have code that was written for a previous game, which has been packaged into a useful library, and you just integrate it into your new code. Windows is designed to make this easy, to make it easy to reuse code, repurpose code, sell code, buy code, so you can efficiently assemble running projects. So malware authors can put malicious code in a DIL. They can use Windows DILs for malicious purposes, and they can use third-party DILs. This is another trick. You can use, say, the Firefox Connect libraries instead of the Windows Connect libraries, just to do something unusual that might sneak past antivirus scanners. So DILs are almost completely identical to EXEs. They're portable executable code. There's just a flag in the header that says if this is a library or an EXE. And of course, DILs have many exports, which are ways to enter. They may offer 50 or 100 functions, and so they'll have exports where you can enter my code at all these different locations where you get the different functions. An EXE typically only has one export, which is the start, like main. All right, so domain is the main function, not exported, but this is called whenever you load or unload a library. This is where the code runs that prepares the library for use. It's run once when you automatically when you load the library, and then you call the exported code to call the functions. So every program is a process, and each process has its own resources, its own handles, and its own memory. So each process is isolated from other processes. They don't collide and undo each other's work. And so the process is broken up into threads in order to make it more efficient. So if one thread is waiting for something that's going to be slow, like a hard disk read or waiting for input from the user, if other parts of the program can keep moving, they move forward in other threads. All right. You typically have 100 or more processes running at any time. Here's 50, and I think this is probably an old Windows XP box I had. You go to your task manager, you'll see how many processes are running. Windows is running a ton of processes all the time. You see some of them run as student, which is my user account. Some of them run as system, and some run as other system profiles like network service or something. These are the system ones are ones typically launched before you logged in, and therefore it couldn't run under any user account, and they have the highest privileges. The system account is the highest privileged process, more privileged than the administrator. It's all right. So each one has CPU, file system, and memory, and two processes that access the same memory address are actually, if you hard code the address in the code, they will still access different locations in RAM because they work in a virtual address space, like a virtual machine. So almost every EXE thinks it's loaded at 400,000, but they're not really. They're each located somewhere else. That's a virtual address. They think they're at 400,000, but they're really located wherever the operating system chose to put them. So you create a process. You can do it with one call. Your startup info parameter has handles for standard input, standard output, and standard error streams. And you can set them to a socket so it can take input from a network connection and send output to a network connection, so you can have a remote shell, where it takes commands from over the network and returns them over the network. Here's code to create a shell. You load socket handle. Just you get their socket handle, so you know how to refer to it. Then you here's where you define standard error, standard output, and standard input. Then you determine your current directory, the environment, some flags, and command line, and so on. And then you define some more parameters here, and then finally you call create process. Notice this process, this is real important, I mentioned it before. The way you call a function in Windows is you push all the attributes onto the stack. So here they are going, everything's getting pushed on the stack. Push the process information, push this to line up all the parameters on the stack. Then you call the function, and when you enter the function, it's going to look on the stack, and whatever it finds there, it's going to assume these are my arguments. It doesn't know if you actually remembered to put the arguments up there or not. It just assumes whatever's there, I'm going to use those for arguments. So you can often have problems caused by this, like format string vulnerabilities, where you call a function and it now refers to memory and does something with it, but that memory was not properly initialized with the right values. So it does unexpected things. So a process is a container that contains threads, and threads are what actually gets units of CPU time. So threads have their independent sequences of instructions. They execute for the CPU. All the threads share the same memory space because, of course, the threads want to save data, and then another thread will want to read that data, and so on. There's called a thread context. While a thread is running, it controls the CPU, and other threads cannot affect it. So when it decides it's time to stop executing this thread and let another thread execute, it saves all those values in the thread context, and this is called a context switch. When you stop what you're doing, you switch to the other thread, load up those parameters, and run that, then you go to the next one. Those are context switches. So you create a thread here, specifying a start address. And so you can use create thread to load a malicious DIL into a process. You create two threads, one for input and one for output. That's one way to do it. There's a lot of ways. Now, if you might want to have a mark that is supposed to be visible to other processes. Like, for example, you're running malware. You would like to mark the system and say, I'm already running this malware. So if the user clicks on an attachment or something and tries to load the same malware a second time, I would like to notice that and not bother loading the same malware a second time. So these things are called mutexes or mutants, and these are just handles in the memory space, which are handles in the operating system that are visible to other processes, so they can read what's stored in that handle and tell that that something has happened. This is how you send signals to other processes. So you can wait for a single object and then release a mutex when you're done with it, create a mutex, and open a mutex. These are various ways to write a mutex, and here's some of the code that does it. It's going to open a mutex and create a mutex with this name, HGL345. So this is often useful for indicators of compromise. Some malware uses a fixed name for a mutex to mark that this box is infected, and when the malware analysts figure that out, they can just quickly scan the mutexes on a box to see if it has this, and then you know it's infected. That would be nice. All right, let's try another Kahoot. 7B. I'll wait a few more seconds. People still coming in. All right. All right. Switch library contains bind and accept. Yep, WS232 are the Unix raw socket libraries from Berkeley, and that's what those functions are, among others. All right, where do you find internet read file? Yeah, WinINet, the higher level function that a normal developer would use rather than using raw sockets. All right, what type of file differs from an exe by just one flag? DILS, a dynamic link library. A library is almost identical to an executable, with very small differences. All right. And a global object that can coordinate multiple processes. Yeah, mutexes, like handles, are objects that can be read by multiple processes so you can indicate something to another process. All right. All right, good. All right, we got a little more of this to do. Let's take a 10-minute break.